Hi, folks. Mr. Dell here. We are going to look at a graph that has been established that has a couple scenarios happening, answer the questions that deal with intersection, and to kind of figure out what does interpret this graph based on the information they give us. So it's interpreting a graph with some steps involved. So I'm going to take this problem is from CPM course 3, and it's section 5.2.1, and it's problem number 5-28. So let's read this together. So Gail and Leslie are riding in a friendly 60-mile bike race that started at noon. The graph at the right represents, or the graph down here at the bottom, represents their progress so far. So this is our graph. If we're going to interpret this, what do I see? I see my x-axis, or this is my x-axis. It's time of day. So here's 1 o'clock, 2 o'clock. So it starts at noon. So it starts us off at noon, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, etc. And then distance in miles is how far they traveled, right? They're going on a 60-mile bike race. So this is the distance. So there's 10, 20, 30, 40, 50, 60. So there's our distance in miles. So it asks, what does the intersection of the two lines represent? So that's the first question it's asking. So given this graph, if I want to know what does that mean, what does the intersection of the two lines mean? Well, let's look at it. Let's analyze. The intersection is right there. So if I use a ruler to kind of see where I'm at, I can kind of bring my point there down to see where that is on the graph. And then the point across is right about here. So that intersection point tells us what? It tells us when Leslie caught up with Gail. Because if you can see that Gail gets out of the gate faster, right? Gail's line is steeper at first than Leslie. Leslie is this one single shot. So Leslie looks like she's going at the same pace. Gail increased, what came out a little faster, but then what's happening here? As staying at the same place for that time period. So that intersection point is, we could say, is where Leslie caught up with Gail. Okay, that's what I'll say for that intersection point. You can also say it's where they're at the same place, the same mile marker, the time and the time and the distance are the same. So those are all other things that we could say in that. And then it asks, at approximately what time did Leslie pass Gail? So we look, that's that intersection point where Leslie now gets ahead of Gail. And where is that? That looks like, if I drew my line down, I've got it at 2 o'clock. So at approximately, because our line might be a little bit off, but it looks like 2 o'clock to me. So at 2 p.m. And then about how far had Leslie traveled when she passed Gail? So if we look, how far has Leslie gone? So that's, again, now the distance over here. So that point, where is the distance? You could argue that might be, this is going by 10, so that looks like maybe at 18 miles. So I'm going to say at approximately 18 miles. And it says, what do you think happened to Gail between 1:30 and 3 o'clock? So if we look at 1:30, 1:30 is here. So that's where the Gail's line starts to go just horizontal all the way to 3 o'clock, right? So at 3 o'clock, from 1:30 to 3 o'clock, Gail's line is horizontal. What is that saying? That she stopped. So we could say, there's a few things you could say. You can say Gail stopped for a break. You could say that she had a flat tire. You can make up all kinds of little scenarios of what happened, but the issue is she stopped moving forward. Gail stopped for a break. She had a flat tower. She stopped moving forward. Stopped moving forward. Okay? Because time keeps going and she's standing still. All right, last one. If Leslie continues at a steady pace, when will she complete the race? So if I need to figure out at what time would Leslie complete the race. So if I take her line, I'm going to continue Leslie's line to determine that. So you'd actually want to get a ruler, somehow a straight edge to see where would she complete. And I realize I ran off the page there into my writing. I'll use a different color so I can see it. So where is the completion of the race? Well, the completion is at 60. So I need to figure out what is the point that her line hits 60. So it looks like right there is where it hits 60. So then I'm going to figure out where that is as far as time. And what that looks like to me, if I bring it down, it looks like 7 p.m. So if Leslie continues at a steady pace, she'll complete the race at 7 p.m. All right, there you go.